In section 4.2, we're going to continue with what we did in section 4.1 and again try to answer yes/no questions about a single population mean. And it's really the same sort of question as in 4.1, but if you'll recall, in section 4.1, our process only worked if the sample size was large. So in 4.1, we required our sample size, which we'll always write as a lowercase n, to be at least 100. So n had to be greater than or equal to 100. And why did we require that? Well, there were two reasons. One was that this means that the central limit theorem applies. So in particular, our sample means are normally distributed with mean mu and standard deviation sigma over the square root of n. That required a large sample size. But the other reason was that the population standard deviation, sigma, when we have a large sample, should be approximately equal to our sample standard deviation s. And so what this meant was that we could do this whole procedure where we calculated z equals x bar minus mu naught over s over the square root of n. And what we knew was that these values, as we vary across different samples, are normally distributed with a mean of 0 and a standard deviation of 1. And that was what was going on in the background, right? When you're doing these hypothesis tests, you're probably not constantly reminding yourself that. However, hopefully you were noticing that you needed large samples. Now, lots of statistics is done on large samples, especially as computers become more powerful and we have more and more large data sets. This is often the case. So this is a useful technique, but we also have lots of situations where you have small data sets for various reasons. And so in 4.2, what we're going to do is we're going to deal with the situation when n is less than 100. And what's going to be really nice is that what we do in 4.2, the motivation behind it is to deal with small samples, but it will also just work for large samples. That is, when we have a sample above 100, the approach in 4.2 will give us almost identical answers to what we would get in 4.1. And the idea of 4.2 is that we'll say, okay, if n is small, so in this case, n is less than 100, then these values that we were calculating, we can still calculate them. Right? We still have all of this information. There's no issue with us being able to compute this, but we shouldn't call it z anymore because z always refers to a normal distribution for us. That's a constant symbol we'll use when things are normally distributed. So instead, I'm going to call it t. So we can still calculate this thing. We'll now call it t because we're not trying to suggest it's normally distributed. And as it turns out with small values of n, this thing is no longer normally distributed. But it does have a consistent distribution. That is, we know how these things are distributed. It's not a normal distribution, but we can just type a command into RStudio that deals with this different type of distribution. So instead, it follows what is known as a t-distribution. And things are a little bit more complicated. With a normal distribution, it didn't matter what the sample size was. I mean, the sample size had to be over 100, and it showed up in the computation, but then in the end, it just followed a normal distribution. Up to mean and standard deviation, there's only one normal distribution. With t-distributions, the sample size does matter. So it follows a t-distribution that depends on the sample size. So that's what's going on in 4.2. We're going to address this situation when n is smaller. And as it turns out, a lot of what we're going to do is very similar, right? The thing we're calculating is identical. We just call it a different thing. The command we'll have to type into RStudio to get our p-values will be a bit different. It won't be pnorm, it'll be pt. And the whole process, as I'll mention, I'm not going to go through it in this video, but there is another video where I'm going to go through an entire problem where I work through one sample t-test for a population mean. So hopefully that gave you a sense of where we're going in this section 4.2.